I hope I'm recording.
It says you're recording.
Okay, thank you. All right, so dismiss, and let me know if that shows up. So here is the rationalizing the denominator. So go ahead and write down these three. And we're going to rationalize those three. I got 4 examples for you. Now this is going to come in handy when we get to the limits. We haven't got to limits yet, but we're going to get there. Hopefully some of y'all can remember how to rationalize the denominator. Can anybody tell me in the discussion board, can anybody tell me why do we rationalize the denominator?
Because you can't have a fraction in the denominator.
We got a fraction in the denominator. Oh, wasn't that nice, Mr. Anderson? To make it pretty.
I don't actually know why we rationalize the denominator.
You're right.
I was told because someone doesn't like it, but we don't know.
That's what I've always heard.
To get rid of the radicals. Somebody said to get rid of the denominator or something. Somebody said that a while ago. You were right, half right. You've got a radical in the what? Denominator. And you want to get rid of it. Now later, when we're doing limits, you can't have what in the denominator? You can't have 0 in the denominator. So sometimes you're going to be forced to rationalize the denominator so you won't have 0 in the denominator. So that's why you got to know how to do rationalizing the denominator. So
why would a radical in the denominator make it a 0?
Well, square root of x minus 2. Okay. 2, you could put a 2 there. 2 minus 2 is 0.
Okay, I see.
So you've got to get rid of the x minus 2 to make it. And that's not a good example because I can't think of a good example off the top of my head. But sometimes you have a radical in the denominator, and it gives you a problem with the limit that we're going to go into next after review. Okay, so here I'm going to multiply by the square root of 2 over the square root of 2. And the reason that is because this dictates what you rationalize by. And that's going to be equal to the square root or 2 or 5, square root of 2 times 5 over square root of 4, which is 5 times square root of 2 over 2. Okay, now is that a test question? Probably not, unless I like y'all and I'm feeling good when I put the test together, then chances are you might get a couple of those. All right, this one, I'm going to break this up into the square root of x squared times the square root of x over the square root of y to the 4th times the square root of y. And of course, that's going to give me x, square root of x over y squared, square root of y. And then I'm going to multiply by the square root of y over the square root of y. And that's going to give me x, square root of xy over y to the 3rd. Okay. Okay, those are kind of simple. You're not going to see these with limits. This is just a little bit of remember how to do this. You're not going to see these with limits, but these are the type you might see with limits. And there'll be an X in there somewhere, and it'll make things difficult. So let me just move to the next page because I'm running out of room here. Let's make C let's put C right here. 6 over 3 plus square root of 7. Now, can anybody remember from high school or Algebra 1 and Algebra 2 or 101 and 102? Can somebody on the discussion board, message board, chat board, whatever, tell me there? Thank you, Mr. O'Quinn. Okay, you're reading my mind, bud. How'd you know that? Good job, both of y'all. How'd y'all know I was going to ask that? Dang old foretelling the future. All right, so I'm going to use the conjugate. Can somebody tell me the definition of a conjugate in layman's terms?
You swap the minus. Well, if you're doing D, you swap the minus for the plus and put
Exactly. I know what you're talking about, Mr. Prebeck and Ms. Hart. You are correct. The opposite operation, write that down. The conjugate is equal to the opposite operation. And if you take the conjugate of A plus B, what is the conjugate of A plus B?
A minus B.
And that will give you shortcut number 3 that some of y'all still don't want to learn. Okay? So far in getting ready for calculus, we have used shortcuts number 1, number 2 in completing the square. And now we're using shortcut number 3 in rationalizing the denominator. Seems like to me you need to learn those shortcuts. So I'm going to multiply here by 2 plus the square root of 3 over 2 plus the square root of 3. I'm going to multiply here by 3 minus the square root of 7 over 3 minus square root of 7. Okay, now I want you to take your knowledge of shortcuts that you have mastered since yesterday and take your knowledge of distributing a number across a polynomial and see what you come out with. So go ahead and take a minute. Let's see what time it is. It's 3:31. I'm going to give you 1 minute. See if you can finish those two. So how is your classes going? Other than this one? Anything amusing?
Only other class I have right now is chemistry, and it's chemistry. So.
Were you going to say something, Ms. Hart?
I said physics is not fun, but.
Who you got for physics?
Kevin Williams?
No. I had
he's all right. He's just not super knowledgeable about the software you use.
That's fine. You just hit records videos and you have to watch them and try to learn.
Yeah, I'm supposed to be taking physics right now too. Actually, my physics class is going on right now, but I don't know how that ended up working out. So I have to go back and watch the recordings from that lecture.
Be happy. I had Dr. Connard at Clemson, and he taught in the auditorium of Connard Hall. And luckily, Connard Hall had like 4 or 5 blackboards that slide up and down. It was the biggest. Had the biggest blackboards and the most blackboards that you could slide up and down.
Absolutely love that room.
Yeah, it's still the same way.
Yeah, I had my organic 2 lecture in there.
I had 3 physics classes in there with Dr. Connard, and Dr. Connard was a little petite. He was like Dr. Harden. Dr. Harden was my calculus teacher. He grunted a lot. Mr. Harden didn't grunt. Dr. Harden didn't grunt, but he had this Amish beard. And it went down the chin line and went down there, and he looked like an Amish. And I asked him one time if he was Amish. He said, hell no. But I had 3 physics in that class. Oh my gosh, in that. Oh. Yeah, you know what? If you had a chemistry or a physics or a biology is usually in Lee, but I don't know if they still use Lee Hall, but that's
Usually
where
in
they
bracket.
bracket. Yeah,
Yeah.
bracket. I'm sorry. Anyway, oh me, do I miss those days? Hell to the no.
We had 80 students crammed in a room in Daniel for my Organic 1 lecture. I was in Organic for majors with Dan Whitehead, and we got, luckily for Organic 2, he's like, I got us a bigger room. And we were in that
in there because that room only can hold like 50
Oh,
or
I know. We were crammed in that, and I had to like stand in the seat to see the boards. So when we moved to Kiner, it was nice.
Yeah. Does it still have the 4 or 5 sliding blackboards?
Oh yeah.
They don't work so well, and he would get pissed and slam them up to the roof because they wouldn't want to move. But it worked.
Well, good. All right, we got 5 times 2 plus square root of 3. And if you want to take that further, that would be 10 plus 5 square root of 3. And that's on the top. And then the bottom, I'm going to go ahead and put it in shortcut number 3 form. That'd be 2 squared minus square root of 3 squared. And that's going to be 4 minus 3 and the square root and the square cancel. That'd be a 3, and that'd be a 1. So the answer is 10 plus 5 square root of 3. And then this one is going to be 18 minus 6 square root of 7 over 3 squared minus square root of 7 squared. And that's going to cancel that radical. And you're going to get 9 minus 7 is 2. 18 minus 6 square root of 7 over 2. Always reduce. 9 minus 3 square root of 7. Now, what I'm trying to tell you is, what did I start with right here? I started with a fraction, didn't I? I ended up with a non-fraction. Started right here with a fraction. Ended with a non-fraction. Remember this when we get to the limits. Okay?
Does it always work out where it's a non-fraction?
Yes, always, because you're taking out. Now, every once in a while, you might have a number down here. You might have a number like 3.
Like for pre-cal, when I was working some, I would.
Yeah.
Okay.
But the main thing is you won't have an X down here, and if you do have an X,
You did
it
something
will be
wrong.
to where it won't make it 0.
Oh, okay. Okay.
Okay? All right, so that's one review. That's one aspect of review. So what have we gone over so far as review? Well, let's go over that right quick. Polynomials. Polynomials being add, subtract, multiply, and divide. Polynomials are also called functions. And then we went over the FOIL. We went over reverse FOIL. We went over the shortcuts. And we went over 3 levels of completing the square, 1, 5, and 10 of completing the square. And now we just went over rationalizing the denominator. Question, can you rationalize the numerator? Yes, you can rationalize the numerator, and in some calculus classes, you will do that. Give you an example right quick. 2 minus the square root of 3 over 7. And let's say you wanted to get rid of the radical in the numerator. Again, you would do it due to limits. You do this also in differential equations. You remove the radical from the numerator. So I would multiply by 2 plus the square root of 3 over 2 plus the square root of 3. And that would give me 2 give me 4 minus 3, which is 1, over 14 plus 7 square root of 3. Y'all check my shortcut in the top, though. I think that'd be right. 4 minus 3, somebody check me. So you can rationalize the numerator, and that's just for later. You should be able to do that. If you can rationalize the denominator, you should be able to rationalize the numerator. I mean, yeah. Although you don't do it as much as you do with the denominator. Now, we're going to talk about functions again, and we're going to talk about composition of functions. Now, this is going to come in handy. Composition is a 25-cent word for substitution, okay? And you don't use it like substitution, but do you remember? Let me back up here. Do you remember back when you solved the systems of equations and you had 2x plus 3y is equal to 7 and y is equal to x plus 1? Y'all remember that? What would you do with that x plus 1? You can just type it in. What would you do with that x plus 1? Yes, plug it in. So 2 times x plus 3 parentheses x plus 1 is equal to 7, and that's called substitution. All right? Composition is like substitution. For those that have forgotten it, 3x plus 3 is equal to 7. 5x plus 3 is equal to 7. 5x is equal to 4. 5x is equal to 4/5. If I did the algebra right, that's substitution. All right, back substitution would be taking that and plugging it back in for x and finding y. That's substitution. Composition is like substitution, but you got to know how to do it. All right? And a lot of students don't know how to do it because the teacher never explained it to them. If I give you a composition function and I say, and I don't want to write it on here. If I give you f composed of g, fog. If I give you f composed of g, that means I'm going to rewrite f with a big ass set of what? Parentheses. And I'm going to plug in, since g is secondary, I'm going to plug g into those what? Parentheses. Now, if you remember that right there, you'll never have a problem with composition of functions. F is going to you're going to redraw f with a big set of parentheses. And then you're going to plug g into those parentheses. No matter what's here, the first one is going to be drawn with a big set of parentheses. The second one is going to be be plugged into the parentheses. And I guarantee you, there ain't many teachers that teach it like that, because that's how I learned it. Because the teacher would get up there and do all this f of x and g of x and f of g of x and get in there and do all that, and I had no idea what they were talking about when I got finished. I got out of class. Okay, so let's do one. Let's do a simple one. Let's do f of x is equal to x plus 4. And g of x, I'm going to use animation here. I'm going to impress y'all. G of x is equal to x to the 3rd power. That's supposed to be green. The hell, you can't even tell it. Sucks. That's supposed to be green. I'm sorry. G of x is equal to x to the 3rd. That makes it worse. So the first thing, if I want to do f composed of g, then I'm going to draw x plus 4 with a big set of parentheses. And then I'm going to plug in x cubed and simplify. If I want to do g composed of f, I draw g with a big set of what? Parentheses, and I plug in what?
X plus 4.
I plug in x plus 4. Good. If I want to do f composed of f, I draw f with a big set of parentheses, and I plug in what? F.
X plus 4.
If I want to do g composed of g, I draw g with a big set of parentheses, and I plug in g. That's all composition is. But you'd be surprised on how many people they try to explain composition of functions, and students walk out of the room lobotomized. There you go. Here's your test question right there. Now we're going to do several. I'm going to write the directions as we go. Let's do f composed of lilac h. F composed of h. Go ahead and do that. And that f of x is x squared minus 6x plus 2. Where do y'all come up with these questions? I got a student asking me out of one of my other classes. Okay, so it's not the calculus class. Y'all ready for this? Do you use a 14-week syllabus for summer, or do you use a 10-week?
You didn't even respond to that one, did you?
Hell no, I'm not going to. Okay. So I'm going to draw my trinomial with a big set of what?
Parentheses.
Big set of parentheses. And I'm going to plug in lilac square root of x, square root of x, and simplify. And of course, I'll do this in blue because this is my answer. F, I'm trying to impress y'all with my animation. F composed of G is equal to x minus 6 square root of x plus 2. And that's basically it. You can rewrite it x minus 6 square root of x, or x plus 2 minus 6 square root of x.
Shouldn't that be f of h?
Yeah, it should be. Thank you. Smart aleck. No, I'm just kidding. You're right. Whoever said that. Who said that? Who said that?
Oh, Quinn.
Mr. Quinn. Yeah, I think Mr. Quinn likes making me look bad. He makes me look bad all the time. Mr. Quinn, why are you doing that to me, man?
Gotta keep it something straight.
It's just somebody's got to do it, right? All right, let's do a nerd. Let's do G composed of F. Yeah, that should make you quit. Right? Actually, it's pretty simple. Yeah, we need to make we'll make a more challenging one here in a second. because we got to get you ready for the difference quotient. So I'm going to rewrite G -2 with a big set of parentheses, and I'm going to plug in x squared minus 6x plus 2. I guarantee you there's somebody out there going, God almighty, I didn't know composition was that easy. May not be a lot, maybe one person. But it's the whole point is it's not that difficult. You've been doing substitution in Algebra 1. You've been doing substitution in Algebra 2 or 101, 102. It's the same thing. You just got to know what this means without all the f of x's and g of x's flying around all over the place. So our answer, GOF, is equal to -2x squared plus 12x minus 4. Mr. O'Quinn, did I get it right?
Looks good.
It's good. I'm glad. Now do me one favor, Mr. Quinn. Will you please do me one favor? Don't do like most of these students. They wait until the very end of the problem, especially when I get into some derivatives and antiderivatives, and I do like 15 lines, and at the very end, that's supposed to be a -4, isn't it? And then I say, yeah, and then all the class goes, yeah, man, that's supposed to be a -4. 2 or 3 don't even know what day it is. Let's do another one. F of x is equal to, and I'll use the same x squared minus 6x plus 2, because I got to get y'all ready for difference quotient. So let's plug in g of x is equal to x plus 5. All right, I want you to give me f composed of g. And I'll do that in blue. F composed of g. Give you a minute to work on it. Okay, so I'm going to rewrite f of x using a big set of what? Now, I am exaggerating, but the reason I'm exaggerating is hopefully you'll remember that that's what you do. Draw a big set of parentheses. And now we plug in x plus 5. Oh my God, we got shortcut number 1. Might as well quit, because that's what I don't want to learn. So that's going to be x squared plus 10x plus 25 minus 6x minus 30 plus 2. Somebody tell me where the biggest mistake maker is in this problem.
The x plus 5 squared.
Not necessarily. That's number 2. Good job. That's number 2. Where is number 1?
Multiplying the -6.
Good job. Who said that? Mr.
Yeah.
O'Quinn?
O'Quinn again.
There it is. Make a note of that. That's going to get you. You got to distribute a -6, not a 6. And that will get you on a test. So let me finish that by putting two highlights right here. There. Yeah, that green don't show up worth a flip. I'm going to have to quit using green. So now you just combine like terms. X squared, 10x minus 6x is dang old 4x. 25 minus 30 is negative 5. Negative 5 plus 2 is negative 3, and you feel good about yourself. So you don't have to drive around a truck with the back end going down like a dog scratching his rear end on the floor. Why does, okay.
They
Question.
have a name. They have a name for that apparently.
Yeah, it's called dumbass.
Yeah.
It's called run, girls, run. Run as fast as you can. My son has a name for it. I get Gibby guy or something. Gibby. I have to ask him what he calls them. There's Daddy's boy, and then there's, I can't remember it. It's like a 3-word guy. Can't remember, three letters. Can't remember. Gitchy guy or something like that. Question on that one. That's a test question. How we feel? Everybody good? Give me a 1, 5, or a 10. 1, 5, or a 10 means good. Let me get a good bunch of y'all. Come on. 5, 10, 10. Okay. I kind of like this conversation chat thing. I like that. Y'all aren't scared to talk with that. This is business calc all over again. Yeah, technically. Well, the review is, yes. I don't cover a lot of trig, and you know why? Because trig isn't the problem. What's the problem with students failing calculus? They can't do the damn algebra. You can do the trig, all you do. What's the derivative sign? Cosine. I mean, that's not a problem. All right, so let's head back now. We're going to go back and talk about something that y'all know about on a graph. Oh, me, I have got to figure out something to do with all these papers. Go back to Algebra 1 and Algebra 2. And let's take a curve, or let's take a straight line. Now, I'm doing this for those 5 or 6 or 10 people that either suck at algebra or they have been a long time since, you know, those 5 or 6 or 10 that said it's been like over 7 years since they've had a calculus or algebra or whatever. I'm doing this for those people. Those of you that was with Aristotle and Galileo when they invented calculus, you can just, you know, work on that cure for Rona, okay? All right, here we go. That's x sub 1. This is y sub 1. This is x sub 2. And this is x sub 1, y sub 2, sorry. All right, somebody tell me what the slope of that line is.
Y sub 2 minus y sub 1 over x sub 2 minus x sub 1.
You are on the ball. You are a winner. How many of you have seen that before? Yeah, you don't have to answer that. I know all of you have. Okay? And everybody goes, well, that's nothing to that. That's the slope. Yeah, you're right. That's the slope, and our good old friend, what? Algebra. Well, Hubert, what the hell does that have to do with calculus? Well, you're fixing to find out. Now I'm going to draw another picture. And I got a little graph, a 3D I got this little calculus in motion thing on my home computer. I'm at my office computer. But you know why I'm not using the office computer? Because it only has one plug in, and I'm using like 5 HDMI plugs right now. And it's only got one. So that's why I'm not using it. And I can't put calculus in motion on my home computer unless I spend $200. And I can't use Geo Sketchpad unless I spend another $300. So I have to do this old fashioned. So old fashioned is a good drink. I've tried it before. It's a good drink. My favorite. All right. So I'm going to switch it now. And I'm going to draw another one. What's the difference in this drawing?
It's not a
It's
straight
working.
line.
It's a curve.
It's a curve. Yep. So I'm going to take my handy dandy red pen. I don't like to use red. Let's use light blue. Somebody tell me what line that is.
Secant line.
Oh my gosh, you must have had a real good teacher in your past.
I must have.
Huh?
Sounds like someone's tooting his own horn.
Secant. The secant line is always on the interior of the what? The circle or the curve. Everybody with me? Now, when you get to civil engineering, that word turns into chord. The chord of the curve. Okay? Flashbacks. Anyway, make a long story short, the secant line is worthless to us in first, second, and third semester calculus. It's useless to us in first, second, third semester physics, because we want to find the velocity and acceleration of a particle in space. That's what we want to find out, okay? And we've got to have the what line?
Tangent.
We've got to have the tangent line. And how do we get the tangent line? Well, there's the tangent. I'm not going to use that color. I'm going to try to use this light green. We're going to get the tangent line right there. And that's the tangent line. Okay, what I'm doing right now is I'm showing you the algebra, and then I'm going to apply the limit theory to the algebra, and boom, what happens when you apply the limit theory to algebra? What do you have? Does anybody know?
Calculus?
You have calculus. So here I am. Here's the first point, and I think y'all know that's called X, and this is called, hold your pinky up, f of X. This one up here, and we'll use a different color. We'll use a peach. I'm not going to call that x of 2. I'm going to call it x plus h with this distance from here to here being what? H. So somebody tell me what this y value is over here. Somebody tell me what the slope of that line is, the secant line. Somebody tell me what's the secant. Tell me, come on, hurry up, let's go. I ain't got time.
F of x plus h
Come on.
minus f of x over
H.
x plus h minus x.
Good job. You are you the man. So m is equal to, I'm gonna use my colors, f of x plus h, which is your y sub 2 minus f of x, which is y sub 1. So I'm going to change that to black. Over f of, or over, sorry, my x plus h, which is my x of 2, x plus h, minus x, and that's supposed to be p, I'm sorry. And what happens to the x's? Now I can use my red.
Cancel out.
They cancel out. And that leaves you with f of x plus h minus f of x over h. Somebody tell me what this is. What is f of x plus h minus f of x over h?
That's the slope of the tangent.
It's the slope. It's the slope of the secant line. But what do they call that besides slope? Because they got to confuse you some way. So they tell you to learn it as a slope for 12 years, and then they change the name of it so it will confuse you. Does anybody know what that's called?
Is it the limit?
Is that the
Not
distance?
yet. We ain't got there yet.
Oh.
It's called the difference quotient. Hold your pinky up when you say it. So what is the difference quotient? It's just a sophisticated way of writing the what? The slope. You'd be surprised on how many people didn't know that. All the difference quotient is a sophisticated way to write the slope. Now, what is the limit theory? Well, the limit theory is basically, I'm going to give you an example of the limit theory. Dr. Harden, bless his heart, he's still got an office down in the bottom of oh gosh. Where they teach all the math classes. What's the name of that one beside
Martin.
Martin Hall, down in the bottom of Martin Hall, down in the basement level, over on the left, Dr. Harden's office got a plaque beside it. He was my advisor. And he was the one that grunted all the time. That means you know how to do this. And I don't know why I'm telling you that. He told me this story. He would use this in the calculus class. You got a wall right here. I'm going to erase this wall. Okay? You got a wall right there. And I tell you, let's say that you've got a stride of 4 feet. And I tell you that I want you to make a step toward that wall. And each step must be half of the previous step. So somebody tell me what the next step would be.
2 feet.
Next step.
1.
Next step.
Half.
1/4. 1/8. 1/16. 1/32. 1/64. Will I ever reach the wall?
No.
No.
You might as well.
Never real reach the wall. But what you will be, think of this. Think of a hairline. Think of a hair between you and the wall. That's how close you want to think about the limit theory. From here on out in calculus, when I talk about the limit theory, I want you to think of the width of a hair, okay, or less. The width of a hair or less. All right, so what in the world does that mean, Hubert? Well, now we're going to apply the limit theory to the algebra that you spent 12 years learning. And I'm going to bring this x right here, this coordinate right here, I'm going to make it go that way. And when I make it go that way, this is just like you, and here's the wall. And what do I want to do? I want to get up to that wall the width of a what? Width of a hair. And when I do that, when I get to here, this X, this drops to here. When I get to here, I drop to here. And you'll see that eventually my secant line turns into my what?
Tangent line.
Tangent line. Now that tangent line opens up everything for you in calculus and physics. Now, nobody's ever going to walk up to you and ask you, Miss Hart, I've got this line here. Can you tell me what the tangent line to this line is? Nobody's ever going to walk up to you and ask you that. But when you are dealing with three-dimensional space, and you're talking about engineering, and you're talking about science, and you're talking about all this other stuff that can go in three-dimensional space, you want to be able to locate a particle in space. You want to be able to tell how fast that particle is going or how slow it's going. And you can't do that unless you find the tangent line, because if you can find the tangent line, then you can find the normal vector. Wow, normal vector. Yes. So tangent line is step 1 in Calc 2, Calc 3. That's your step 1. You're trying to find the tangent line so you can find, take that blue, and you can find, when you find that tangent line, you can find that normal vector. That's what you're looking for.
So is a good way to say what the limit theory is based off of? It's based off finding the tangent line from the secant line?
Yes, it's based on, no, the limit theory only applies to this distance right here. Let me take my handy dandy. The limit theory is only being applied to that distance right here. And what is the domain? What's the relationship between the domain and the range? It's a direct relationship, related rates. It's going to affect the y the same way. And as this one goes to 0, this one's going to go to 0. Thus, we have what we call the squeeze theorem. Okay, that's later. But anyway, the distance is what we're focusing on with the limit right here. So let me take this and do this for you. Limit as h approaches 0. Go back here. What did I tell you this represents beside the wall? I told you the width of a what?
Hair.
Okay, does everybody agree with me that the width of a hair is about as close as to 0 that we can get without using a microscope?
Yes.
Yes.
Okay. All right, so we're going to use that width of a hair in our mind to think out of the box, because you're moving from algebra into calculus with this limit theory. All right, so we're going to take that width of a hair, and that's what we're going to call this right here. Width of a hair. And we're going to take this, and we're going to apply it plus to our algebra. Our algebra is f of x plus h minus f of x over h. And when we apply the limit theory to our algebra of 12 years, that's going to be equal to calculus and finding. And what are you finding? You're finding the equation of the slope of the tangent line at any point on a curve. That's what you're finding. Now, the limit theory is we can spend a week or two on the limit theory. And I'm going to give you some problems on the limit theory. I will. But I'm not going to, I'm on a test of 20 questions, I'm going to give you like 3 because I just explained the limit theory to you. I'm not going to spend a lot of time doing a lot of derivation and mechanical. Can you find the limit? I'm going to explain the limit. We're going to talk about the limit, but I'm getting you ready for this because this is the bulk of your Unit 1 test, what I'm showing you right now. So let's apply this to, I had a question. Where's my question? Well, I must have wrote it down somewhere. Hold on just a second, guys. I had one. I had a example for y'all. Here it is. There's your example. I want you to write that down. 3x squared. Let me check the time. I don't want any of y'all to self-combust.
We got 10 minutes.
Okay, thank you. Now, right now, we're not doing a limit theory, okay? Right now, we're just going to do the difference quotient. Okay, so I just want you to do the difference quotient. You know you got to plug in that x plus h. You got to rewrite this with a big set of parentheses. And then you got to subtract this. And then you got to put it all over h. So I've got 416. Give you 2 minutes to see if you can simplify that down to something over h. Or see if you can get the h to cancel. I don't know if you can or not. Yeah. Dr. Harden was about 4 foot tall. So I'm going to start you off. I'm going to rewrite the difference quotient up in the right-hand corner, and I'm going to use different colors. F times x plus, I'm sorry, f of x plus h, and that's in blue, minus f of x, ugh, I don't like that, ugh. It clashes. Over this is a yellow, but I don't know if it's going to show up or not. Yeah, it showed up good. You know, I can't hardly see it here. All right, so first thing I'm going to do is I'm going to rewrite my 3 parentheses squared minus 5 times parentheses plus 4, and I'm going to put that in blue brackets. Minus, and just rewrite f of x, 3x squared minus 5x plus 4. All that over h, and that's going to be yellow. So somebody tell me what I got to do on the blue brackets. What do I got to do on it?
Plug in x plus h.
I got to plug in x plus h. That's correct. Now it's 100% what? Algebra or calculus?
Algebra.
It's 100% algebra. All right, go ahead. I help you set it up. Go ahead and finish it. Okay, so I'm going to write real small here, x squared plus 2xh plus h squared. And now I'm going to distribute 3, and that's going to give me 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 4 minus 3x squared plus 5x minus 4 all over h. Now, this should happen when you do this correctly. All your x terms should do what?
Cancel.
Cancel, and your numbers should cancel. Not all of them, but most of them. 3x squared, 3x squared. 5x, 5x, 4, and 4. Usually the only thing left most of the time, unless you get into higher derivatives, is the x and h terms, usually. So that leaves us with, and I'm just going to write this in dark blue because we're getting close to the answer, 6xh plus 3h squared minus 5h over h. And I can go ahead and cancel this h with this h, and leaves that a 1. This h cancels with that h. So my final answer of the difference quotient is 6x plus 3h minus 5. That is the equation for my slope. Now, we haven't applied the limit theory. We've just done 100% what? Algebra. You're still in Algebra 1 and Algebra 2. Now we're going to turn the page and we're going to take that algebra. Okay, this is review. Now I'm going into a little bit of Unit 1 and Unit 2. We're going that way. So I'm going to take my answer here, 6x plus 3h minus 5. And that's my algebra. And now I'm going to apply my limit theory. And what happens when you take that 0 and plug it in for h?
The 3 goes away.
6x plus 3 times 0 minus 5, and that goes out. 6x minus 5. So the slope, or the equation for the slope of a line anywhere on that curve, on this curve right here, anywhere on this curve is, I'm going to call it f prime of x is equal to 6x minus 5. Now, Miss Sterling, where am I at on time? About 1 minute
Out.
over? Okay, I'm going to show y'all one more thing. And it's just real quick. Okay, y'all got that written down?
Yes, sir.
All right, now I'm just going to draw a picture of that curve because I know my family of graphs, and I know I've got a y-intercept of 4, and I know it's opening upward, so that sucker can be, and this is what, in business calculus, the first derivative tells you. F prime of x is equal to 6x minus 5. If I plug in and make that equal to 0, 0 is equal to 6x minus 5. 5 is equal to 6x. X is equal to 5/6. So 5/6. 5/6. So that's 1 and 0. If I plug 0 back into this, 0, that's going to give me negative. And 5/6, if I plug in 1 here, that's going to be positive. So that means I'm decreasing and I'm increasing. So that means that 5/6 is on this side. There's 1, there's 5/6. So my graph looks something like that. Okay. Now, I may be off a little bit. I'm not worried about if I'm off. I'm just worried about one thing. If I take -2, and I take -2 up here to where it crosses the graph, there's x is equal to -2. What's the slope of this line at x is equal to -2? Well, what's the slope in 6 times -2 minus 5? What is -2 times 6? -17. So the slope of this line at x is equal to -2 is -17. what is the slope at positive 5? 6 times 5 is what?
30,
30 minus 5 is?
25.
So the slope at 5 is equal to 25. That's what you're finding out. Now we're going to do some more stuff in unit 1 or 2. I can't remember where it is right now. We're going to build on that first derivative, which is your first thing that you learn in calculus. But that's where we're heading. But in order to do this, you've got to be able to do the limit theory, and you've got to be able to find the difference quotient. The difference quotient is pretty much the end of the review. Everybody with me? Okay. Now, I'm going to call the roll, and then y'all can skedaddle. Unless you got questions, you can skedaddle after you know, and probably it's not going to let me call. Probably not going to let me pull it up, but I've been pulling it up all morning, and hopefully it'll put. Shit. This pisses me off. Let me go ahead and turn the recording off. Stop recording. Okay. Let me get out of this and try to pull up the dadgum.
Speaking of which, that file never got uploaded. Or hasn't shown up yet.
I didn't hear you.
file.
What?
The family graphs hasn't shown up yet in the files.
Okay, I'll try to figure out how to do that. Yeah, I want